So, Mehul or Akshay, if any of you have made progress and would like to share, go ahead. I do have a question around using Kaggle CLI in Kaggle itself that I'll wait to ask. Go ahead, Akshay.
Hi, can you hear me?
Yes.
Yes.
Okay, perfect. Um, well, first of all, thank you so much for. I guess Steve is not here, but he shared the kernel, which kind of motivated me to get started with it. Are there any? This is my first time attending this meeting. Are there any rules that should be accommodating not sharing any information with respect to
No,
Kaggle?
this is a completed competition. So the purpose
Right.
of this is more for us to learn and see what techniques work or don't work. The one thing we were trying to do is, the goal is to learn as much. So we were trying to avoid just jumping to the final solutions or the best solutions, but nevertheless, in the earlier meetings, which hopefully we'll get a link to the recording soon, or at least where the recordings are posted. I think Mehul has been following up, and so have a couple of others. And the only thing I would request is that or in the previous meetings, we've gone through, a bunch of observations of how we could use fast AI to approach the problem, but nothing that we shouldn't share or with each other, because basically the competition is over. So this is more of us learning to use these techniques and applying it on a real problem and making progress towards what would hopefully eventually be comparable to the best.
Okay, that helps. Um, so I would like to share my screen. I have a notebook open here. How exactly can I do that on Zoom?
So there's a
think
share
there is a
content
share
button. Yeah, there's a share content button on the bottom.
I see. Got it.
Okay.
Can you see my screen?
Yes.
Yes.
Okay. So I did some EDA and pre-processing. So the usual stuff, looking at the directories, understanding there are 4 files per image. We kind of have to merge the 4 files to create the final 4-channel image, and then process that to create a 3-channel image. So I started with exploring the directory structure, a little bit of data after that. This dictionary and some code I picked from some of the kernels which are available on the Kaggle. Then looked at the distribution of class, which is highly skewed. As you can see, nucleoplasm is one of the classes which appears more than 12,000 times as compared to some of these classes. So that's, I think, just something to keep in mind. And based on this, we might tweak some parameters later, which I haven't done so far. Then, yeah, so this is where I was playing a bit with how the images look. So if you read just one file of the image out of the 4 available, this one is blue, and I tried to plot it. Then I read all 4 files associated with image, and I tried to plot this one. Visually, it seems obviously there is more information when we add all the files for a particular image. And then comes this interesting part where I was looking for resources, how we can convert a 4, I'm not sure if we can call this 4-channel, but distributed information for an image into a single file. And first it was confusing, and the kernel Steve had shared followed this trick where you divide the information from the yellow file and add that to red and green, but not loop. And I looked up, and it seems there are some resources. Quora is not a good reference, but there are other resources as well, which kind of suggest that we add red and green, we make yellow. So the reverse logic is we look at yellow, divide the pixel information into 2 buckets, add each bucket into red and green because they already contain some yellow constituents. So that creates a 3-channel image. And then I tried plotting this. It looks something like this, more yellow than the others. Just for fun, I tried something new. I tried dividing the information from yellow channel by 3, like 3.33, and add to every single remaining channel, that is red, green, and blue, and plotted that. It looks pretty similar to the one we have here, but I couldn't really find any references why we should do this. So I decided to stick with this approach where we are adding half of yellow channel information into red and green. And then I created files to save on disk with the same logic here. But the size for the files I decided to save was 224 by 224. And before FastAI, I was trying PyTorch, and I kind of inferred that ResNet pre-trained models accept 224 by 224. So that's the reason I chose 224, but it seems we could have used 512 pixel as itself. So this is the pre-processing part. 2 things here: added yellow channel information into red and green, and then save the images into 224 by 224. I have that information. I have the data available if you guys are having trouble accessing the G drive, and if you think, since this is a smaller size, it could be easier to share. If you want, I can definitely upload this. Yeah, so that's the first notebook. Then I tried to build baseline model, and this is the version I'm using for FastAI. In here, I did the basic transforms, split 80-20, and then, so we have, I think 30, where is the size? Yeah, 31,000 or something like that images. So in train, we have 80%, 24,000. In validation, we have 6,000 images. So yeah, that's 31,000 in train data. And in test, we have 11,000 images. After that, I use the regular functions of the further resizing to 128, then normalizing with ImageNet stats, and plotted some of the images. ResNet 152 is one of my favorite starting options if it's not a grayscale or 64 by 64 image. So it generally gives better results. And started with these metrics. This is not the metrics which the competition expects, but I thought with baseline, I'll just get something working and then I can edit the components. I was getting this weird error with device attribute not found. So after looking at some of the code, I thought this might work, and it did. So not getting any error with respect to device not found. And use CNN Learner with the data we had built, 152 ResNet, these 2 metrics. Then the learning rate finder points somewhere here just before we hit the rock bottom. So I chose this. Try to fit 5 cycles, and this is the accuracy. Interesting thing is, before I tried 128, I tried 64 or 62, and this is the result. As you can see, if we don't downsize image much, then we might get better results. And I'm inferring these things on the fly. So if I'm concluding something incorrect, please interrupt me and let me know.
Quick question. Are you running it locally?
Oh, yes.
Okay. Also, just FYI, I mean, I hope you don't mind the interruption, or we can hold the question to the end, whichever is appropriate. The one thing, just because we had discussed this previously, is it seems for this kind of model, and I played with it yesterday as well, and it seems to hold for me, is the lower complexity models seem to work better than the higher complexity ones. By that I mean, if you actually do a ResNet 34, that seemed to give better results than ResNet 50 or 150. And it kind of goes back all the way to what Mehul had pointed to, a paper which said that, for these kinds of medical images and stuff, the later layers, that is in 150 deep ResNet, the later layers are much more learning things related to the output. And since the output is only 28 as compared to ImageNet 1,000 layers, they are not as useful. And in fact, the very first or the very second layer is at most what you learn best from transfer learning. So the smaller complexity ResNets seem to do better. And in fact, if you can create your own rest block or dense block of like few layers deep, then you would probably be as good as transfer learning with a deeper ResNet. Just FYI.
Oh, that's very useful. Really appreciate the tip. I'll try that.
And for me, between ResNet 34 and 50, and unfortunately, I'm unable to access those notebooks now. Something went wrong on my computer, but 34 seemed to do simpler than, better than 50.
Okay. Okay, that's very useful to know. I'll definitely try that and share the results, how they perform with each other.
And while we're at it, the very first, where you translated the RGB and stuff. So I took a kind of, in fact, essentially modifying Steve Roberts' network. Steve Roberts' notebook. The approach I tried, just FYI for people who are listening and want to try very simple things, not even converting the RGB like it did, and but just utilizing the R, the G, and the B, and dropping the Y, and just using those three layers. And just going ahead and utilizing that data from all of the images and completely ignoring the Y. And in fact, if you look at at least the pictures of the images, they look as good as anything else. Unfortunately, I ran into some trouble with the final analysis of Kaggle, which is my question later, of how to get why. And I'm running on Kaggle, and I'd like to know how to. Maybe Mehul can point, since I know he has run on Kaggle, is how to get the Kaggle.json file uploaded to Kaggle from a local drive and stuff. But anyway, I think that's a very simple approach you can take, because in transfer learning also, you don't need to do anything to tackle the fourth layer, and just stick with RGB from the channels and utilize that with a ResNet 34 or 50. And unfortunately, I can't share what my final results are, but I'd like to know what it is, because that's the simplest approach you can take.
Sure. I'll try that too. At first, it seemed a little counterintuitive that we might lose some information. But let's see what the result.
No, you're right. I mean, it is not. I assume it would not be as good as including Y, because obviously there is some information in Y, which is why you're provided the data. But I just wanted to start with something ridiculously simple and see where it takes.
Okay, sure.
Go ahead. Thanks.
So with this baseline model, ResNet 152 and the data we have, that is 128 by 128 images. These are the results. And this is the result when the image size was 62 instead of 128. So I'm going to try 512 as it is and see if the initial scores look better compared to this. Then the usual fast AI steps, unfreeze, and then train all the layers. And it looks better, it's getting better. But again, keep in mind, these are not the scores which Kaggle requires. Right. So save the model and tested it on the test data we have. This code is basically we are choosing which labels we want to pick based on the threshold we have. And obviously that means this is another hyperparameter we can play around with. So I started with 0.2 and I submitted here, and as you can see, the validation went up till I think 0.5 or something, 5.3 F beta, but that's not what we see here. And primary reason I think is we use different metrics than the competition required. So that was the baseline model. Then I experimented a little bit. I wanted to add more transform, use slightly bigger images. So last time we had tried 128. This one uses 224. And obviously I had to reduce batch size because I was running out of memory. It seems there is a default option for batch size is 64 if you don't specify anything. And then I was trying to figure out how to get the right metrics. So on Fast AI, they have the metrics. That seems like so. In here, I think it's part of Fast AI metrics. List of all the metrics which are available. And when I was scrolling through these, and towards the end, we have this multi-label beta. So we do have multi-label classification challenge. I looked into this, and then the terminology seems familiar. So we also have macro as one of the parameters here, and then obviously we're averaging. So it seems something which might be exactly what Kaggle needs, and I haven't really explored how this works. So I thought just let's try changing the metrics instead of accuracy and F beta 1. Let's try this. And I use this. So initially it's the usual stuff we are using now. Same 80-20 split and same sizes here. You can see our images look a little bit better because we are using size 224 as compared to here. So that's the reason I'm going to try 512, hopefully gain more information from it. And this, since this is a class, there is a different way you have to call the F beta label. So I declared an object f1 from this class with these parameters, which will be used by init to initialize f1 and then use f1 in key A like this. I'm still not sure if this is the best way to use this information, but it seems after doing this change and increasing the size, the metrics look somewhat believable as compared to the previous one. And then I tried submitting this, and the results are here. It's better than what we had seen with the baseline model. With baseline model, I was getting a public score for 0.20. It's 50% more. And as you can see, I did a little bit playing around with the threshold. So the threshold 0.2 was default. Then I tried these combinations and tried submitting. Since this competition is over, I think there is no limitation how many entries you can submit. And I tried with these thresholds, and this is how the result look. The best I was able to get was 0.31. And as next step, I want to try 512 by 512 images with different ResNet, and as Srinivas suggested, probably less complex ones. So this is where I'm at. Any suggestions, comments, questions?
Yeah, I think that's really great that we made this much progress. And a couple of suggestions that I have is, one is I think even in Steve's notebook he has done it, but he has done it, and there are kernels on the Kaggle website which suggest using all 4 channels rather than converting to RGB. And that, so if you're playing with it, I would say, because yes, just last couple of days I tried with 512 itself on the Kaggle website. Unfortunately, I couldn't get a score, but I was getting the accuracy scores just staring at your data much higher, like 96, 97. Now, I don't know whether it's a good proxy of what it would eventually result in terms of the F1 scores. That's where I got stuck frustratingly. But so the thing is to definitely, as you said, maybe simple, because it's a simple next step is just using the 512 size image. But the other thing I would suggest is utilizing the 4 channels, and then Steve has, I think, based on some Kaggle kernels, a way to essentially create a ResNet 1834 blah 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 using 4 channels. Unfortunately, the thing he has done there is in his notebook is copied or started with zeros on the 4th channel. And what I have observed is it's better if you use the average of the 3 RGB values populated into the Y as the starting point for your transfer learning ResNet with 4 channels. And if you do
you mean the weights
Sorry?
for the 4 channels?
Weights for the 4th channel, yes. So the initial weights, if you look at Steve's code that he has adopted from some Kaggle kernels, is the 4th channel is initialized with zeros. And if you follow some discussions, it's much better to start the 4th channel off the weights again, initialized to be the average of the other 3 channels rather than zeros. And if you start with that and use 4 channels and do exactly what you've done, but on 512 size images, at least I think you'd probably get as far as you can with the basic. That would probably end up being the best score, I think, with this set of parameters. Now, of course, the next thing to try, if you've gotten that far, would be to utilize, because right now you're doing, the basic multi-category classification with FastAI, which is binary cross entropy, and then the next step would be to figuring out a way to combine that with focal loss.
Sorry, can you say that again?
Right now, because you're using, the loss that FastAI uses is binary cross entropy for multi-category classification, and the thing to figure out is to use that in combination with focal loss. And if you go back on our Slack channel, I believe Mehul had posted, and in fact, we even in one of the earlier chats discussed a little bit about focal loss and how it helps improve the loss in a multi-category situation.
Interesting. Sure, I'll check that.
So that how to combine focal loss with multi-category loss, and it's a very, in fact, it's done in FastAI, and Jeremy talks about it in one of the lectures, I forget which. And so there is a way by which you can combine focal loss with with binary cross entropy loss and using FastAI. Just have to figure out and make it work. That would be the next step. If that would be kind of like the third step. The first step is just using 512 with your method. Then the next step would be using 512 but with 4 channels, and initializing with the average of the 3 channels as the starting point for the weights, and then using the combination of multi-category binary cross entropy loss with focal loss.
Okay. Okay.
But that's excellent, and if you can even just post these notebooks, that would be helpful to everybody, and that would really help.
Sure, definitely. One of the thing I was thinking about, I had seen this a few people try in SF crime data set on Kaggle, is when the distribution is highly skewed. They tend to separate out these categories, which don't really add much towards this is not the best way to do it, but I guess they tend to separate out some low frequency categories and train model on the rest and try to predict on the data they have. So this way they don't have to worry about learning something which has very less information about. I don't know the details, but do you guys have any input, any opinion about that?
Yeah, there are a couple of papers. Again, Mehul, I think, posted a couple, and if I can't see it, I downloaded some, so I might even post to the Slack after this discussion is over. There are techniques to use for imbalanced data set. I think one of them essentially is the whole paper and approach on SMOT, I think it's called. Mehul, you probably is.
Yeah.
I think that's and then the other one which Jeremy talks about, which I think is also fairly simple. And then again, I think Mehul posted a more recent nuance around that technique. The technique is essentially oversampling, and basically you oversample the underrepresented classes in the data set. The interesting twist, and I thought it was very fascinating, if I recall correctly, Mehul had posted a paper which said that you're better off oversampling after splitting the data. So what you do initially is you split the data for test and train, and then you oversample within each of the subset. And that way you get a more accurate prediction. Your predictions, not more accurate prediction, your assessment of how good you're doing is closer to what you will eventually get. And that's a twist that was more recently evaluated and posted. I think Mehul posted a link to that paper in one of our Slack. discussion. So that might be something worth trying rather than just, and maybe you can try both and post some result, which is one approach that you mentioned of just ignoring the low frequency and training it on the or low not frequently occurring classes, ignoring them and then training it on the rest and then using that model. And another approach could be splitting the data, oversampling the lower, less time occurring classes in the training and the test set, and then building the model off of that and seeing how that performs.
Sure.
Yeah, and I think for the metric, for the unbalanced, it's like, I think the way we posted the paper, it was a focal loss. And there are, I think, two parameters. There are gamma and a beta. And the paper has some suggestions. It's a paper by Kai-Ming He, who did a lot of the ResNet architecture, and they made a really nice object detector, RetinaNet, and that's in that same paper they introduced focal loss. It's been used a lot in Kaggle also.
I see.
And like Srinivas said, if you can scroll through the Slack channel, there should be all the papers. I don't know if it's easy to find the PDFs, but maybe it is.
Yeah, I can repost a bunch because I downloaded many of them to read through. So I'll just post more recent channels, I'll just post and all those PDFs back again. So.
Sure. Yeah, I think there is some discussion here.
And then one note about the previous recording. So I was just having an individual chat with Mia, and she pulled like the link for one of the sessions from Amazon Cloud. So I just shared it, but I asked her to, like, she said she will post the recordings for all our sessions on Kaggle on YouTube. But if you see my link, it's like a really long path that she had to fetch from Amazon Cloud, and she said it might take her some time. But yeah, I've got one of the links from her, but still waiting on getting all of them, and hope getting them on YouTube. I don't know if Joseph is here, if you got your links on YouTube already or still waiting.
Yeah, I do see he's on the chat, though he's muted. So.
That's okay. Yeah, but that's where we are with the recording. Sorry, just a slight detour, but yeah, I thought I'll just mention it.
Yeah, no, multiple people have asked, so thanks for that update because it helps.
Mm-hmm. Sorry, this is Joseph. I just heard your question. Could you repeat it again? It took me a while to get myself because the screen was behind something else.
I know. Yeah, Joseph, I got one of the links for these Kaggle recordings from Mia. It's a long Amazon Cloud link.
Yeah, it didn't work. I tried it. It didn't work. I thought I had retrieved the last the session before last. I'll ask Mia. Well, they do get automatically recorded, but then you have to do something to get them to get the recordings processed. Because you have to. There's a web interface where you set the start time and the end time. Because there's a lot of things that sometimes before the recording starts, there's a lot of nothing that happens, and you want to just select the right start time, and then you have to select the right end time, and then you forward it on to, you set up the job for the thing to be completed, and then it goes to Mia. So, are you on the moderators list?
Yeah, I am.
Okay, so I think she said how to do that. How to do that on that list. I'll check.
Oh, I see.
And,
okay.
And so the people who run the meetings are the ones who have to make sure that the recordings get processed.
I see.
Yeah, I mean, I think Mia will do it eventually, but it won't get done quickly if you wait for that to happen.
Right. Okay. I see.
Yeah, if you guys want to share that link with me, I can see whether I can do some of that. Mehul, since you're traveling, feel free to drop me a DM or whatever, and I can try and get that done because I'd like to go back and listen to some of that myself too.
Okay,
Right. Yeah. Some of our.
I'll dig that up and pass it on to Mehul and you, Srinivas.
Thank you.
Thank you.
And while we are on the subject, Mehul, could you maybe, if it's of relevance to other people, at least it's, I'm stuck. If are you using Kaggle to run the notebooks?
I have recently, since I'm traveling, I haven't done much, but in the past, yeah, I have used Kaggle to run the notebooks.
Okay, in which case, either here or on Slack, could you quickly describe or post, how you were able to, where I got stuck is it required the Kaggle JSON file to be in the root /.kaggle, and when I access the API and try to get it, it downloads to my local download folder, and I'm stuck as to I'm sure there's wget or ACPS, something by which I can transfer it over to the Kaggle directory, but I don't know how.
I see. Yeah, I was thinking about your question when you mentioned it. So normally, in general, you only need that Kaggle.json if you're running locally. So when I ran, for example, when I ran on the Kaggle kernel, so basically every competition has a data set, right? And
right.
when you start, I didn't start a notebook from scratch. Like, I took somebody's like starter kernel, and the data was already attached.
Yeah, no, the data is attached, and even for me, so it, or at least, when I started the notebook, I was able to access the data and go from there, except that when I submitted to the competition, it still said, oh, I can't find the kaggle.json file in root /.kaggle. And because of that, now I created, the directory, but then I didn't know how to copy or how to get the JSON file. I mean, I can access the JSON file locally, but I didn't know how to get it to where it needed to be. I can do that in Colab too, and I've posted on our Slack how to do it on Colab, but now I can't do it on Kaggle.
Oh, and when you're making the submission, are you how are you making the submission?
I'm using the Kaggle CLI, using bang, blah blah blah.
I see. Okay, I think that's the difference. What I did is I just made the kernel run and create a CSV file, right? And when the output, I think there's an output tab, and there is blah blah blah. Okay, that this is submission.csv, and then there is a button to like submit. So I didn't, when I submit, I used the Kaggle, the GUI button. I haven't submitted with the CLI on Kaggle. Like I only use the Kaggle CLI when I'm running locally.
Oh, I see.
But
So if anybody else,
your question now.
Yeah, so if anybody else has done it, because now I'm stuck behind that, it's really frustrating because I'm at the last part of submitting and getting my result access, and I'm dead.
Yeah, you could do one thing, like if you have your Kaggle kernel, if you could share it with one or two of us. I think there's a way to, like, if you just like look us up by our Kaggle usernames, then you can say share with only like
yeah, let me try that, because now this morning my notebooks have disappeared, so I have to go hunt. I don't know what happened, but I might be able to recreate that fairly quickly. But yes, I'll do that if that's an approach. But I just thought, since multiple people might end up using Kaggle, it'll be good to know how the hell to do that.
Right. Yeah.
So if anybody else on the call figures it out, I'd request them to share that with the Slack group.
I think Steve is not on this call, but I think he must have figured it out, because I remember like when he showed
Steve has, because and in fact that was going to be my next question to you and or Steve, because I think the two of you have used Jovian, and that would be another thing. It would be good if maybe you or Steve share, and obviously Steve has done a lot more with Jovian. If we can share how to set that up and how to track, because Akshay, for your information, actually, if you look at Steve's notebook, which he shared in the last discussion last week, Jovian seems to help keep track of the many runs that you have done. I have not used it, and so I've kind of gun shy of jumping into learning yet another thing, but it would be useful if somebody can go over it and take us through it step by step. And definitely Steve and possibly Mehul, if you are familiar, then you can do that in the next chat as well.
Yeah.
Interesting. But is it something we can do on local machine as well?
Yes, I believe so.
Yeah. Mm-hmm.
Okay.
So
great.
Yeah, basically, like just this 35,000 feet picture is you run your notebooks on Kaggle, but if you want to share your notebooks, you can share it on that Jovian platform. So for example, before I would share on GitHub, but GitHub has some lot of problems with sharing notebooks. So this and also Jovian has some more features, like Srinivas was saying, like you can track your experiment runs automatically. And Steve, last time in the last session, Steve even went one step further. And so for example, I was only tracking experiment parameters like number of epochs, iterations, learning rate. He also managed to track the Kaggle public and private results on Jovian by doing some API call to Kaggle and getting the results file from Kaggle. And I think his notebook has that. And I think, I remember correctly now. He said he used, so he was using the Kaggle GPUs to do his experiments, right? And he said he would like start on Monday and run out of GPU time by Thursday, right? Like in just 3 or 4 days. And he did submissions by Kaggle CLI. So I can take a look at his notebook to Srinivas for the Kaggle.json question. Like it should.
Yeah, he's used some other way by which he loads it onto some file initially, and maybe I'll try that. But I avoided that, tried to do it bare bones, but this is the problem I ran into.
Can you try one thing? Like, can you copy, like, so in Kaggle, you have a workspace, right? When you do your notebook, and if in the same, directory, if you can copy your JSON, Kaggle.json file, and it might, it can look at that directory, or I'll check some more if there's a way to pass a path to the Kaggle.json file. Yeah.
Okay.
So right now it's looking in tilde dot, you said dot.
That's the default place where it wants it. The problem is I have access to it, but I have access to it locally. So how to get it from my local or from any location on the web, but it happens to be, I have it downloaded and I have it on my local stuff. I know how to get it onto, for example, my Google Drive, but I don't know how to get it onto the Kaggle location.
I see. Okay. Yeah, if you share your notebook, I'll give it a try.
Yeah, I'll definitely, it may take me a day to get my notebook back in shape, but I'll do that. Anybody else want to share any thoughts or anything, any next steps that people?
So I have a question. When we change the size of the input image for one of these pre-trained architectures, FastAI takes care of the additional changes in the architecture. So what happens to weights in that case? The additional or in some cases less number of weights?
The size doesn't have an impact on the weights. I mean, I shouldn't, that's not, I didn't say that correctly. What I meant is the dimensions of the weights don't change. The values of the weights do with the change in size, but the dimensions of the weights don't change with the change in size, right?
Maybe I'm a little confused. Is that correct to say the ResNet family accepts 224 by 224 by default?
Good question. I think it is somewhere in, at least for FastAI, the default size is 224 by 224. I don't recall whether for all ResNets that is, although I'm tempted to say it is. But that's something worth double checking. But for FastAI, the default size is 224 by 224, I believe.
Okay, I had tried something in PyTorch as well with a FastAI. And I might be wrong here, and I'll also explore more. But I thought it was 224 by 224, and that's the reason I keep converting to 224.
Yeah, no, you're right. PyTorch also, by the way, the other thing to notice is, in fact, if FastAI downloads the ResNets from PyTorch, so it's not FastAI's, it's basically PyTorch's models.
Right.
So it's essentially PyTorch models of ResNet that FastAI uses. It's just the vision part of it uses the ResNet model that PyTorch has pre-trained. So it is the same. It's 224 by 224. But the point is that what I was saying was that the ratio of the weights don't change with the dimensions of the weight don't change with the size. The values might.
So if you're using a grayscale image with, let's say, PyTorch without FastAI, then one of the things I had seen people do is take average of the widths because it's only one channel, or copy the grayscale values into two additional channels to make it a 3-channel image. So that was kind of the reason why I was trying to understand this overall change in dimension scenario.
Yeah, but that's true, right? Because if you, that is related to the channels aspect of the weights, meaning how many layers, not layers, how many channels you have. But I was just talking sheer width by height is what the size aspect is related to, right? See, the width by height is what determines size of an image.
So for the weights of first layer, wouldn't it be corresponding to the height by width by channel, the dimension of weights for the first layer? It's okay if there is no quick answer. Maybe
yeah,
we can explore.
I'll worth looking at to see if you maybe right in I might have been quick and wrong. It's worth discussing and looking at further. I'll definitely look at that, because my intuitive thing was that, you know, the size, but size, as you're saying, might have an impact on. So it's worth discussing. Bring up a good point. Maybe I should be more careful and look at it in more detail before I speak. So, worth checking into. Definitely do that. And post an update on Slack, maybe.
Sure.
Yeah, one of the techniques definitely that that you're trying, and in fact Jeremy also recommends, is training on smaller and then proceeding to bigger, or even training on smaller and then trying to predict bigger sizes. I mean, so.
So would that somehow help us optimize the workflow? I'm planning to test or build the model on 512 by 512. So should I train the same model which I have built for 128?
Sorry, could you repeat? There was a lot of echo on the line.
Sorry. So considering the Jeremy's comment that we can train the model initially on smaller dimensions and then move on to higher dimensions, would it be helpful to optimize the workflow I'm planning to work on with respect to 512 by 512 images? So should I start training the model on something with lower dimension and train the same model then after I'm done the lower dimension on 512 by 512?
Yeah, that's what I think he recommends, at least that I have seen. So that's one reason he says, even if you're doing 512 by 512 or 1024 by 2024, train it on the 224 by 224, or even sometimes, 128 by 128, and then move to bigger images, bigger dimension or bigger size images. Yes. That's at least what I've heard him recommend in multiple instances.
Okay, I'll try that.
Okay, it's exactly 11. Anybody else want to share anything specific? Or I think it'd be good if everybody can kind of get to, last time we said download the data, as I mentioned, Colab doesn't work, so you might need, and by the way, I subscribed even to the Colab Pro thing, and even that didn't help me unzip, so that was a wasted $10. Although it speeded up a lot of other things I'm doing on Colab. But I think stick to Kaggle or Paperspace or something else if you want to do the data, but unzip the data and work with it. And, it would be good if everybody kind of got to the place where they're playing with it and getting some results, as Akshay is or as Steve Roberts has been able to do. So that would really help us kind of move to the next step of what parameters to tweak and what other approaches and laws and or other techniques that we can use to move forward as a group. Anybody else have anything else to add or contribute? If not, thanks everybody for joining, and hopefully we'll have Steve here next week as well, and we can learn more about Jovian, and also Akshay may be able to share more of the results of the experiment, and hopefully more of us, including myself, will be able to speak about some actual results. Thanks, Akshay. Thanks everyone else for joining. Bye.